The strategy we've sketched so far is to take all the places that our type checker used to check whether two types are equivalent and get a yes/no answer and then give a type error if not. Now we can't just compare two types because one of them might be a type variable or have type variables inside it. So more generally, we just need to unify these two type variables. We'll have a unify function. This is a more general operation than just comparing them because in the process of trying to compare them, it may install an equivalence in one or the other. And there may still at the end be some things unknown, but they have to be unknown in the same way. Our unify function is either going to succeed quietly or it's going to complain with an error. So if it succeeds quietly, it'll just return the void value here instead of a Boolean. It'll be up to unify to complain with a type error if it can't make things match. In the real code, we'll also pass in an expression so that when unify complains, it can point to some relevant expression that may help the programmer using Mo track down where things went wrong. Unify is going to install type equivalences, but in various cases, we may encounter a type variable and we want to know what has this been set to. Not for doing comparisons, because that's always Unify's job, but by printing out the resulting type, say. And so we're going to have this helper function called resolve that takes a type and just resolves all the type variables that have specific constraints on them to show a simpler type. That is, if resolve gets a type variable where there's no constraint on it, it'll just return that type variable. But if somewhere along the way t1 has been unified with int, it will have installed an equivalence between t1 and int, and its resolve job to take t1, if you give t1 the resolve, it'll just return int. Similarly, if t1 has been unified with int and you give resolve t1 arrow t2, it'll simplify what it can. The t1 will get replaced by int, while t2 will just stay as it is if it hasn't been unified with anything. But later, if we unify t1 to t2, then resolve of t2 will not say t1. It'll keep going through and find the simplest form, int. So these are two new functions that we need to write, resolve and unify.